In 1950, it took 2 years to build a house. In 2025, this machine builds one in 24 hours. Not a small house, a full concrete structure, earthquake-resistant, insulated, plumbed, ready to live in. Dubai has committed to 3D printing 25% of every new building by 2030. Texas just printed an entire neighborhood of 100 homes in the time it would traditionally take to build 3. This technology isn't coming. It's here. And the construction industry, worth $13 trillion globally, will never be the same. This is exactly how they do it.
Welcome to full-scale manufacturing. Forget bricks and mortar. Today, we are 3D printing an entire city.
Before a single layer of concrete is printed, this machine has to be built first. What you're looking at is called a gantry printer. Think of it as a giant 3D printer, but instead of printing plastic, it prints concrete.
The gantry is the foundation of everything. People focus on the concrete mix, on the nozzle, on the software. But if the gantry
spans the entire footprint of the building, sometimes 20 meters wide, 30 meters long. And it has to be perfectly level. Not approximately level, not close enough level. We're talking laser-verified precision to within 1 millimeter per 10 meters. Because the print nozzle moves at up to 500 millimeters per second, at that speed, even a 2 millimeter error in the track level creates a visible defect in the wall. The gantry rails are set into concrete foundations and adjusted with precision-machined screw jacks. Every joint in the track system is checked with a digital level that reads to 0.01 degrees. This setup process takes 48 hours before a single gram of concrete is printed. Because everything that comes after depends on getting this right. Regular concrete cannot be 3D printed. It's too thick. It clogs the nozzle. Too thin, it collapses before it sets. What this machine needs is something engineers call printable concrete. And getting the formula right took over a decade of research. The base mix contains Portland cement, the same material in every concrete structure ever built. But then it gets more specific. Silica fume is added. Particles 100 times smaller than a grain of sand that fill the microscopic gaps between cement particles and increase density by 30%. Polypropylene fibers, each one thinner than a human hair, are blended throughout the mix. These fibers are what gives 3D printed concrete its crack resistance. When a conventional concrete wall cracks, it propagates. One crack becomes many. In this mix, the fiber network stops the crack from growing. Then, the chemical accelerator. This is the ingredient that makes everything possible. Without it, the concrete takes hours to set. With it, each printed layer reaches structural strength in under 4 minutes, strong enough to carry the next layer. The entire batch cycle, mixing to printer nozzle, takes exactly 6 minutes. Because if the concrete sits in the pump longer than that, it starts to set inside the equipment. And a blocked nozzle mid-print means starting over. The first layer is the most important one, not because it's the foundation, but because every single layer that follows references the first one for position. The print nozzle moves along a pre-programmed path, generated from the building's architectural model, accurate to within 2 millimeters. Each layer is 38 millimeters high. Each layer is 50 millimeters wide. The walls are printed hollow, not solid. Inside each wall section, the nozzle traces a Z pattern, creating internal ribs that interlock between layers. This is not a design choice. It's structural engineering. A hollow wall with internal Z-pattern ribs achieves 85% of the compressive strength of a solid wall, at 40% of the concrete volume. Less material, same strength, less cost. Every 6 layers, the printer pauses automatically. A human technician walks the perimeter, placing electrical conduits and plumbing pipes into the hollow wall cavities. Then the printer resumes, sealing the conduits inside the wall. No chasing, no cutting, no patching. The building's infrastructure is printed into it from the beginning.
Printing a single-story wall is complex. Printing a multi-story building is a different problem entirely. The printer can only reach so high before the gantry becomes unstable. For most systems, that's about 3.5 meters, one floor. So once the ground floor walls reach full height, precast concrete floor slabs are craned into position. These slabs sit in recesses, printed into the top of the walls, designed into the model. Printed automatically. The floor slab drops in. No mortar. No adjustment. The printed recess is precise, enough that the slab simply drops to the correct height. Then the gantry system is raised. The printer tracks are extended vertically on the outer wall surfaces, and the entire gantry climbs to the next level. This process takes 4 hours per floor. The printer then begins the second floor walls, directly above the first, continuing the same digital model, one layer at a time. A 2-story structure, from ground to finished walls, takes 72 hours of print time. Conventional construction, the same structure, takes 12 weeks.
keep it steady, almost there. All right, looking good from this end. Yeah. Ready to snip when you are.
Finally finished. What a day.
I know, but look at this place. It's beautiful.
We should order some pizzas.
We used to think in years. Now, We think in weeks. This isn't a new way to build, it's a new way to live.